Now, in this course, so far, we have learned very briefly to do statistics in 1 and 2 sample situations. That would be my one-liner to tell you, what have I taught you so far? To do statistics when we're looking at 1 or 2 groups of data and we are focusing on the means and or the variances of those, right? I did it based on normal distribution, sort of classical tools before the fall break, and then I did it by simulation tools last time. Same sort of thing, the same purpose, but a different set of tools. And at the same time, I used those very basic settings to teach you what statistics really is, at least the inferential statistics, which is the topic of this course. That is 2 one-liners for you so far: hypothesis test and confidence intervals. Generic tools, statistical tools, and the whole thinking around it, right? The whole framework around it. So we spent quite a bit of time, in a way, doing that on this very basic setting of 1 and 2 group data, something we've been looking at for decades even, right? We started in 3rd grade to compute an average. And in a way, such basic ways of looking at the world are in fact used a lot, even though they're so naive, simple, that you almost cannot imagine compared to the complexity of the world. Such simple approaches are used a lot because, in a way, all complex situations we can encounter out there in our future engineering life, either in business or in science or in public administration or whatever, could potentially be seen through the filters of this simplicity, looking at 1 or 2 averages. That can be used for many things. Many complex things can be sort of split into atoms in a way and looked at by such a simple-minded way. So that is why these basic tools and basic approaches are very, very, very important. However, they are not sufficient to get to the real understanding and analysis of the complex world that we will meet. It is not enough to get the full picture, to just be able to decompose it into 1 and 2 groups data and look at it like that. It can often be done, but you lose the overall picture if you do like that, in many cases. In many cases, what will hit us out there is more complex. And we need also, when we are going to learn from data in more complex settings and more complex realities, we need to use statistics to do it in an intelligent way, and more so as years go by. So, today, the remaining part of the course, we will take 5 steps towards more sort of complex structures in which we should also be able to do statistics. Right? We have 8, 9, 10, 11, 12, and then the last one is a summary. So 5 new topics, in a way, 5 new small worlds I will open up for you. And then please remember, our course here is just 1 out of 20 courses at this university in statistics, right? And we're just 1 out of 10 universities in Denmark giving courses in statistics. And Denmark is just one little world, one little country in the big world. It's also a little world, of course. But anyway, but hey, don't worry. Enjoy life while you explore it. Here it comes. Regression analysis. Something that we have all also encountered previously. We have an 8-point plan, 3 before the break, 3 after the break. And then we have a little visit just before the break. Let me start with the example that you have already met in chapter 1. So it's a situation that we briefly met already in chapter 1, namely the situation where we are not only measuring one thing or recording one thing, we are recording 2 things. So now we have, again, you could say 2 columns in our data set, but the new thing compared to consider it as 2 groups is the fact that we are going to look into the phenomenon of such 2 things potentially being related to each other. And And sorry for the naiveness so far. I guess if you didn't do it in 3rd grade, you probably did it in 4th grade in elementary school the first time, made a plot like this, maybe in 2nd grade if you were at a nice school. It depends. So it's not the first time you meet this. And if you've had other interesting courses at DTU, physics, chemistry, whatever, you would have seen scatter plots and relations like this. Previously, it's not the first time. Here is the one we use as a little example in the note, the height-weight example. So the idea is that probably it looks like that there could be potentially a linear relation between the weight, between the weight and the height. We see the height potentially as a linear function of weight, right? That is probably not too wrong way to look at height and weight relation, at least among more or less grown-ups here. We see the 10 persons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, come in different heights in centimeters and weights in kilograms, right? And we plot the weight in kilograms versus the height. We've seen this all before. The new thing here is we're going to link this and we're going to apply statistical reasoning, statistical thinking. And I'm going to share with you what we can use that for. That is probably maybe new now for you. Maybe you've thought about how to compute the line. I will repeat that, not in all detail, but I will tell about it. But we are going to do statistics, and in a way, as I do sometimes, I show you the final result, and then we dig into it to understand how we get to this final result. When you are going to do statistics in the future, linear regression, what you will do in the future is just write something like this. Hopefully, expectedly, you'll probably still use R. If you don't use R, you can do a similar thing in Excel or any other software you might use. Basically, you tell the software, you put the heights into the X, you put the weights into the Y, you find a function in your software. In R, it's called LM for linear model. There is a function in R called LM, linear model, that can do all of it for us. You write something like this, and this is a classical R syntax. This tilde thing in R is used to say Y is a function of X. And R understands what we mean. This is kind of an R syntax to write y tilde x. Then it will spit out a number of things to us. And I'm going to share with you most of these things, and a few of these things we don't care too much about. But most of the things I will tell you about. First thing to notice is it spits out the line. What is the line in this case? The line is the line with slope 1.113 and intercept minus 120. That is where it hits the 0 point, right? The y-axis. This is the line that I plotted. So this is actually the line. We call them beta 0 and beta 1, beta naught and beta 1. That's our name for slope. Sorry, for intercept and slope. And then it does stats. And that's what I'm going to teach you now, right? You don't know what is here. But it does some stats. Look at it. It has some standard errors that we can use for confidence intervals. It has some t value and some p value, so you can recognize some of these things. We're going to do some stats related to such a line. And then it has also the word residual. We're going to learn about that residual. That is what is left in the y. That is what is unexplained in the weight. Even though we try to explain the weight using the height, it's not 100% explained, right? There's still some noise going on. And this noise is on average 3.9 kilograms. So people are on average 3.9 kilograms away from the line, in a way. But I'm going to teach you all this now. I'm not going to show you the R to produce these lines. It is shared with you in the material. We're going to get back to those later on before we finish today. However, the red and the green lines here are effectively the statistics part of it. which comes from the statistics information that I showed you. Again, I'm just telling you about it now to get you the idea of what's going on here. So we're going to find the line, and we're going to do some statistical reasoning thinking, realizing that this line is not the one and only truth. It could have come out some differently, right? That's the new thing. A line is not just a line. That's the statistical thinking. The same thinking that I've taught you for an average or two averages, for a mean or two means. That goes to the line also. It could be positioned differently. It could be sloped a bit differently next time I sample 10 persons, right? And the red, these are actually the red lines. They are there to show that statistical uncertainty on the line. And then the green ones have another interpretation. I'll get back to that. That's the challenge here. There's different possibilities of using such a line. This was, very briefly, what we're going to do today. Do the line and do the statistics around it. Right? So let's get moving. Second part. For that, we are talking about statistically, mathematically, probability, theoretical, if